In continuation to our last lecture, today we'll be starting up with semantic nets. Let me first tell you that semantic nets, this lecture part, has been taken up from NPTEL lecture series version 2 of CSE IIT Kharagpur. Right. Now, I totally want to say that all the materials that are there in this slide and further for the next 2, 3, or 4 lectures, they're all taken up from the NPTEL lecture series. Now, I'll be providing you with these slides, and I have gone through the video part of it, so I'll try my best to explain you some of the things which I feel is important for you to know in the knowledge representation part. Right, I again say these materials or these lecture materials are not mine, they are taken up from NPTEL, right, of IIT Kharagpur. Today we'll be starting up with knowledge representation formalisms. Right, now what are knowledge representation formalisms? These are the basic or the preliminary ways by which we represent knowledge. One of the ways which we have gone through is the logic representation in our initial lectures. Today we'll be seeing all the possible, today and in the next few more lectures we'll be seeing all the possible ways of knowledge representations. Now, some of the abstract knowledge representation mechanisms are as follows, right? The first one that we'll be talking about is a simple relational knowledge. Obviously, remember that this is the lecture on semantic nets, but to understand it in a much better way, we need to know these formalisms first, then we'll be moving gradually towards the semantic nets explanation. Now, a simple relational knowledge. Let's say we are having a relational table out here comprising of musicians, their style, the instrument that they play, and their ages, right? We all know that in any relational knowledge or a relational table, we generally do what? Now, it's a way of storing facts by using a relational method where each fact about a set of object is set out systematically in the form of columns. This representation gives little opportunity for inference. Now, here is a beautiful statement. This representation gives little opportunity for inference. What do I mean by this? Drawing inference or deducing inference is something that which means to extract more and more information from the previously provided information, right? But it can be used, that means this simple relational knowledge can be used as a knowledge base for inference engines. How or what are the qualities that we know about this simple relational knowledge is that they are the simplest way to store facts. Each fact about a set of object is set out systematically in the columns. That means this is how we store facts, and each of the fact about an object is set out systematically in the form of columns. Let's say I'm having the fact as musicians, right? I'm having a particular musician like Mike or John or Frank or another John. Their style, the way in which they play the music, right? And the instrument that they play and their age. They give, now what is the third quality? They give little opportunity for inference. You cannot infer something from the stored information, which is sorted and stored in the form of columnar structure or in fact in a tabular format. Now the knowledge basis, they, even though you cannot infer, but they form the knowledge basis for the inference engines. That means in a way they are the base or the groundwork for gradually moving towards the semantic nets inference engine backdrop, right? Let's say I am having this information in front of you. That means musician, style, instrument, and age. From this information, what are the facts that we can extract? We can ask things like who is dead. That means you can fire a query that find out the names of those musicians who have died or whose age status is deceased. That means they are not alive. So you can ask a thing. Here we are not talking about firing queries. We are talking about ask things. As I have already said you in the lectures previously also, since we are modeling AI based systems, so here the queries are not basically fired. We make it much more human computer interactive, and that's the reason why we go for asking questions. So instead of firing a query, we just say that we are asking questions like who is dead, or who plays jazz, trumpet, etc. Right? That means you can even search a musician on the basis of his style. That means the name of the musician who plays jazz, or the name of the musician whose instrument is trumpet, right? So you can fire out these two queries, or you can ask these two questions, and these things can be extracted through a simple way of inference extraction like structured query language on this relational table, right? Now, this sort of representation is popular in case of database systems. Now, they have clearly said that these kind of representations are especially for database systems, whether they are relational or not. Next comes the topic of inheritable knowledge, right? We are here at the inheritable knowledge. Now, the relational knowledge is made up of objects consisting of attributes and corresponding associate values. What does this thing means? Now, in relational database table, what are the things that we do have? We do have a particular entity. Those entities do have attributes and the corresponding associated values for them. Like here, if it is a musician table, I do have the attributes like musician's name, their style, the instrument, and the age. These are called as the attributes, and their particular values are provided here in the form of a tuple, right? We are having four tuples here, the first one, the second one, the third one, and the fourth one, right? Now we extend the base more by allowing the inference mechanisms. Now this thing can be done by which way? Now by knowing the property inheritance. How can the property inheritance be done or performed? Now the elements can have property inheritance on the basis of inheriting the values from the member of a particular class, or when they are organized into a hierarchy of classes. So property inheritance is about elements that inherit the values from being members of a class, or the data must be organized into a hierarchy of classes, right? Now let's see what are they talking about belonging to a member class and the hierarchy of classes. We are having a typical example out here. Now, before we move for this particular diagram and its explanation, let's talk about like the boxed nodes that you see here are objects and the values of the attributes of the objects, right? The values can be objects with attributes and so on. The arrows point from object to its particular value. That means if I am at Mike Davis, the musician's name, so the arrow is pointing towards jazz, means he plays this particular type of music, right? So the arrows point from object to its value. This structure is known as, now we will not be talking about this now. Let's see this diagram first. Let us start up with our object. The object is Mike Davis. That means that particular individual or that particular musician. He's having an instance, right? This instance is what? Now this instance is as a musician he's playing a particular type of music, that is jazz. We can see the same thing out here. John also does have an instance where he is having this jazz and another type of music that he plays. So Mike, Miles Davis and John, they both hold an instance in which they play a particular type of music. Now, this jazz is under the is a inheritance. This jazz talks about Miles Davis that he is what? No, he is a musician. And in a much more generalized fashion, he is an adult male having an age of 35. So, in a way, if you start looking from this level and gradually move to this, and then to this, and then to this, it is a bottom up approach. So, relating these kind of knowledge representation to the schemes that we used to have in databases, we can say that it is the case of generalization and specialization. So if I'm moving from bottom towards up, I'm talking about generalization. If I'm moving from the top towards the bottom, I'm talking about specialization, right? Here I do have a more vivid generalization, like even though I'm moving downwards from Davis and John towards this part, that means when I'm talking about their bands to whom they belong, it is a much more specified one rather than it should have much more generalized one, whether where it should have been much more specified, right? So here you can see that this is a kind of a chain where we are talking about the instance and there is a inheritance, like, so we are going to say that Miles Davis plays the music of jazz as an instance, and is a musician who is also an adult having an age of 35, right? Now we are having a very simple algorithm to retrieve a value for an attribute of an instance object. What we are going to do, let us talk about this algorithm. Let us see what it is doing. Now the algorithm to retrieve a value of an attribute of an instance object. What is my instance object here? That is Miles Davis. If I am getting its value here, it is fine, or else I'll be taking about this object's first instance value, that is jazz. If it is there, it's okay. If it is having further chaining and we can come up with its is a value, then I can say that Miles Davis's further specified value going through the instance and an is a inheritance is musician and adult male. So the algorithm says find the object in the knowledge base. If there is a value of the attribute, then report it, right? Otherwise, if it doesn't carries that value, then look for the value of that instance. If none fail, otherwise go to further move on and find a value of the attribute and then report it. Still, if you're not finding it, then go for an is a case until a value is found out for that particular attribute. That means gradually you move up from the object class towards its more and more specified version, right? Now inferential knowledge has been very clearly and vividly described earlier also. It is nothing but representation of a knowledge in the form of formal logic. In case of formal logic, what we do is, like we have already gone through, all dogs have tails, so for all x where x are dog, x has tail. What are the advantages of inferential knowledge? That means formal logic. Now, a set of strict rules are implemented that can be used to derive more and more facts, and truths of new statements can be verified. These verification is done on the basis of what? Now, on the basis of the rules that has been pre-assigned, that means from the knowledge base, and guaranteed correctness. Obviously, as long as the rules hold true, it guarantees the correctness of the values that are inferred, right? Many inference procedures are available to implement the standard rules of logic, popular in AI systems and automated theorem proving, right? Now comes procedural knowledge. What is a procedural knowledge? The basic idea is that the knowledge is encoded in some procedures. We are having small programs on how to do a specific thing and how to proceed. This is implemented as a parser in a natural language. This is the second point I'm talking about. Parser in a natural language, an understander, and a knowledge that is a noun phrase. Now, what are the advantages? The advantages are heuristics or domain specific knowledge can be represented, and extended logical inferences such as default reasoning is facilitated. That means this is provided. The side effects of actions may be modeled. Some rules may become false in time. Keeping track of this in a large system may be tricky. Why? Because continuously my rule base gets updated, and if it is not updated, then some of the inferences or the deductions may not hold true as we move further and further, right? Now, these were the advantages. Let's talk about the disadvantages. Disadvantages of procedural knowledge. The disadvantages are, the first disadvantage is completeness. Not all the cases may be represented. This is one of the disadvantages, right? Not all the cases may be represented. What is the reason for this? All the cases may not be represented because of the hard facts of the hard rules that are implemented. Like if an animal does have feathers, so it is a bird and it must fly, right? It may not have the condition that even though it is a bird, it may have the instance that it may not fly, right? Consistency. Not all deductions may be correct, and this is where we talk about the extension of the completeness. Let's say if we know that Fred is a bird, the name given to a particular bird, we might deduce that Fred can fly. Later, we might discover that Fred is an emu. An emu is a bird, even though it is a bird, it cannot fly. Modularity is sacrificed. Why modularity is sacrificed? Now the changes in the knowledge base might have a far-reaching effect. That's why the modularity is always sacrificed and compromised. That means the knowledge base may change, and it always does have a far-reaching impact. So completeness is one of the disadvantages, consistency, modularity, and the last one is cumbersome control information. Obviously, since you have to follow a lot of procedures, hence it becomes more and more cumbersome to control the rules that it governs, right? Now, the following properties should be possessed by a knowledge representation system. This is a generalized one, right? The following properties should be possessed by a knowledge representation system. Now, representational adequacy is one of the properties that a knowledge representation system must have. Representational adequacy is what? Now, to represent a required knowledge, the ability to represent a required knowledge. The second one is inferential adequacy, the ability to manipulate the knowledge so that we can produce a new knowledge. Inferential adequacy is about producing a new knowledge. And inferential efficiency is about the knowledge that we have produced, its direction of storing and appropriate guides. That means how we are going to use that knowledge that has been already produced. The fourth one is acquisitional efficiency. Acquisitional efficiency is the ability to acquire new knowledge and using automatic methods wherever possible rather than reliance on human intervention, right? That means since I have to acquire more and more knowledge to make the system much more efficient, so we should not only rely on human intervention, rather than we should have automatic methods whenever possible to acquire that particular knowledge, right? Now, Gradually we are moving towards the semantic nets, right? Let's start it in the next class now.